It started like any other morning until everything at Deceptitech went dark. In just minutes, every critical system was locked, encrypted, and it went offline. Well, the IT team scrambled to restore from backups. The security team rushed to their scene only to find everything wiped clean. Nothing found, no backups, no data. So what they did not know that the hacker was already inside. Using stolen credentials, the hacker was able to slip into the core server, encrypt the file systems, and while everyone panicked, they quietly stole the latest CRM data and customer exports. And all of these data were hidden inside a password-protected archive. The data was exfiltrated to external buckets controlled by the attacker. The hacker left no traces. Event logs were wiped, the sharded copies were deleted. They thought that everything was wiped clean, but in this video, forensic investigators, us, we have a single clue. We're going to piece together the timeline, unmask the tools used, and prove the exfiltration before it is too late. That's the story of the CRM Snatch room in TryHackMe. We're going to analyze the scenario first by going over the diagram, first the network topology, and then dive deep into the investigation. Let's get started. Okay, now if we look at the network diagram, we see that the server that we're going to investigate is actually located within the core subnet. This is the subnet that hosts the domain controller and the users connecting to the domain controller. It's basically the internal subnet where most of the employees or the users are actually located, or their endpoints. So here is the server, the targeted server, which is the compromised server. And off this server, the data was exfiltrated, or the CRM data was exfiltrated. That's why the room is named CRM Snatch, because the attack at this stage, which is stage 4, we're interested in, it is at that stage the attacker exfiltrated the data from the CRM server off to a C2 server they control. So this server is the targeted server we're going to investigate in this challenge. Now, the DMZ subnet is it's another network that's logically separated from the core subnet. You see, the IP addresses are totally on different subnets. Now, the DMZ subnet, it's the subnet that the attacker actually used as a piggyback, right? So by compromising one of the servers, I'm not sure which server, it's not written here how the attacker got, or which server they compromised in the DMZ subnet, By compromising one of the servers in the DMZ subnet, they were able to obtain credentials for a user named, you see now the user named here is, it is stated as Matthew's stolen credentials. So through the credentials stolen by the attacker were able to pivot from the DMZ network into the internal network, okay? We have other parts of this network, and basically they are the AWS environment. It includes the online storage buckets, and we have the remote users. Basically, they are employees who connect using VPN to the DMZ servers. These employees, it's not clearly stated whether they connect to the internal network as well through the use of VPN. But it's pretty obvious that the remote users usually connect to the DMZ network, because usually DMZ subnet is the subnet where most of the resources exposed to the internet are located. Like you see, we have Deceptitech web, Deceptitech demo, Deceptipot, sorry. Here we see it looks like this is the honeypot, and this one is the web server. Now, these parts, of course, in this room do not matter. What matters is the CRM server, which is located entirely in the internal network, in the internal subnet. And usually resources on the internal network connected to the central domain controller are actually harder to reach than resources connected or located in the DMZ subnet, simply because these resources are not supposed to be exposed to the internet, right? So say if one of the remote users wanted to connect to the CRM server, they should have a VPN or a set of VPN credentials connect to the VPN server in the DMZ, right? And then from that connection, they can then connect to the internal network. So they need to use a VPN, okay? And yeah, that's my viewpoint on the network diagram. Now, in the challenge, through the given statement here, we're given the impression that the attacker, as I said earlier, they got hold on the CRM server. They exfiltrated data of the CRM server and they wiped the logs clean. Your job, or our job here, is to find out what happened, establish a timeline, unravel the tools that the attacker used to exfiltrate the CRM data or the customer data, and prove a case of exfiltration. So now you see, that's the piggyback point. from the CRM or from the server DMZ GW located in the DMZ subnet, this server, they were able to pivot to the CRM server. So now we're going to investigate the CRM server by logging into the CRM server. So basically here we're given a disk snapshot, a forensic disk snapshot of the disk. It's located basically, okay, so clicking on image, that's the snapshot of the disk here. And we're given the forensic tools required to perform the investigation. The first thing you want to do here is to fire up access data. You want to mount the disk snapshot to be able to browse the file system. So after opening up access.ftk imager, you want to mount. So by clicking on the mount icon here, image mounting, you select the source. So add image, select image file, locating the disk snapshot. Okay, you see now the mount type, the drive letter, and the mount method are automatically pulled depending on the image type. You see now the mount type appears to be physical and logical. The drive letter is D, you can change this as you want, and the mount method is block device read only. Now keep this as read only for the time being, and we're going to click on mount. Add drive failed. So when you see this error, unable to mount the partition, this means we may need to make some changes here. So you're going to select logical and select mount still. If we put this back to physical and logical and select maybe a writable version. Oh, okay. Let's have a look. Maybe it was mounted. Oh, okay. So we're going to close this, and maybe reopening the tool would help. Let's remount the tool, edit the image, selecting the CRM Snatch. Okay. All right, so you see now we have a new drive from here. Let's close this, go back, opening up file, the file navigation, this PC, and now we see a new logical drive. So the first question here is, which domain account was used to initiate the remote session onto the host? So we go back to the machine, and from here we're gonna head back to the mounted disk, which happens to be D in my case. So clicking on users, and here you see a list of all the users registered on the system. Among them is the only user we can actually find other than the administrator, which is Matthew Coens. That's the username used to infiltrate the remote host. For how many seconds did the attacker maintain their PowerShell session active? This one is a tricky question because there are multiple ways to find the answer. Usually we find the duration of the PowerShell session using the Windows event logs. So usually we focus on security event logs and Microsoft Windows PowerShell operational. From there, if you filter for process create and process terminate events, we'll be able to count or to calculate the approximate time of the PowerShell session. However, in this room, this wasn't possible, at least in my case. Therefore, I pivoted into the other method, which is using something called the user assist. Usually, user assist is used to gauge the interactive time of each process. Okay, so by finding or focusing on the user assist, we can actually find the focus time or the interactive time used on the PowerShell session. So basically, that can be used by loading the registry hives. But which registry hive is we're going to load? It is the NT user dat. So we're going to click on file, and from here we're going to use load hive. I'm going just to head over to users and locate the user we're interested in. And from here, you see we have the NT user dat. We're going to open this, and hopefully I will be able to locate the user assist from here. Okay, so from here, we're going to click on available bookmarks, and we're going to search for the user assist. Okay, luckily we found it. Let's have a look. Click on the user assist, and let's see if we have a search function here. This one will search on the right side column. We don't want this. Left side, sorry. So we're going to scroll down looking for PowerShell. It should be easy to find. program Windows PowerShell, not this one. Okay, here it is. So Windows PowerShell v1.0 PowerShell. If you look at the focus time, we see it lasted for 57 minutes and 35 seconds. Okay, now if you convert this into seconds by multiplying it with 60 and adding 35 seconds, you will end up with the exact number, 55 seconds. What was the attacker's C2 IP address used for staging and exfiltration? Now for this one, we're gonna have to, the machine has a bit of delay, sorry for that. I'm gonna have to head back to users and then locate Matthew Collins, click on app data, and from here, click on roaming. Usually roaming has the list of all the tools along with the logs related to them if you want to inspect them. So we want to focus on PowerShell. I'm gonna click on Microsoft, and then from Microsoft to Windows, PowerShell. I'm looking for the console logs, the console history. The console history shows you all the commands, all the related artifacts that were spotted in the, or were used in the, or during the PowerShell session. So you see here, the attacker used system information and sent the output to system info to have a look at the system information. That's an example here. So all of these are the commands used during the PowerShell session. We see instances of using rclone here because rclone is a tool basically used to copy data between two machines or between the a machine and, of course, an online cloud bucket. In this case here, it's used, of course, to exfiltrate data. You see the attacker used invoke web request multiple times to connect to an IP address to retrieve payloads or executables. And here, this command, the attacker used rclone or invoke web request to connect to the C2 server, retrieves the rclone executable, and then, of course, later down the road, the attacker used rclone. Scrolling down, let's see. You see here we have invoke web request again to retrieve exfil temp.7z, temporary file used to exfiltrate the data. Scrolling down, here we see credentials, a username, and a password. The password is given a value which is megapass. Looks like I'm gonna have to find this. Here we have a password. So the IP address here is this one, and which well-known tool used to exfiltrate the collected data? It is rclone. Next, we have what is the obfuscate password to the attacker-controlled Mega. Mega is a tool or is an online platform used to download and upload files, file sharing platform. So here the question is to find the obfuscate password to the controlled, attacker-controlled Mega, which means not this password. We're looking for this password here. You see, we have variables defined during the PowerShell session. The first variable is type, then user and password. The password is not clearly defined here as a plain text. It is just defined as a obscured variable, megapass. We're gonna have to find this. Well, at first, this may sound a little bit tricky, but we're gonna have to trace the logs backwards. So we're gonna scroll up and we're gonna start over from the point where the attacker started to retrieve tools from the C2 server. So we see the attacker retrieve a couple of tools like psexec, and then rclone copied a couple of items to program data sync. So if you head to this directory here to program data, and then we have sync, we see the tool that attackers actually downloaded from the C2 server to the victim machine or to the machine that hosts the CRM server. So we have 7z, backup win, we have Mega configuration, and we have psexec. Before being tempted to quickly open up Mega, let's now go back and see what happens later, because you want to establish a timeline of events and, of course, the chain of actions the attacker has followed to do the exfiltration. Okay, remove a couple of items from the same directory, and then attacker defined variable named URL, which happens to be the C2 server IP plus the port 8080. And then you see, guys, here we have the CRM HTTP-conf, the configuration file of the CRM server being exfiltrated. And then here the same thing goes. Scrolling down, we have an invoke web request again to the attacker control server. And again, here we can see, guys, that the data has been wrapped up in a file named exfil.temp. As I can see here, config program data sync CRM HTTP-conf, and was copied to the destination is exfil.temp. basically this is the file containing the exfiltrated data. All right, here we go. Then after that, we have definition for a couple of credentials, user, pass, and it was sent to the configuration file mega.conf. So probably the answer here is the configuration. The answer lies within the configuration file mega. However, you see how the attacker actually obscured the password. It's something we need to find out. So you see here the variable name password was created, and the value of this variable was derived from executing this command. You see backup Windows, which is a tool the attacker retrieved from the pseudo server and stored in the victim machine. And then it was given the keyword or parameter obscure and this password. This password was defined earlier. You see, guys, when the username and the type was defined, and it looks like the output of this command holds the obscured password. But the original password it could be this. However, if we open up the megaconf file and have a look here at the credentials, I'm going to copy this first to make sure to copy all the files you want from the mounted disk to the desktop of the given machine, because they are read only, and the only way to modify them or read them is to copy them over. So you can open this with Notepad. You see now the type is mega user. This is the attacker username, and that's the complete password. Let's try this. It worked. What is Lucas' email address found in the exfiltrated data? So that's the attacker controlled email. If you go back to the logs, so you're looking for username or user named Lucas, whose email address is required or found in the exfiltrated data. Now, if we head back to sync file and take a look at the CRM HTTP conf, remember this file was spotted, used in the partial commands, specifically zipped into the file named exfil. And this file represents the exfiltrated data, supposedly. Let's see. Opening Notepad. And from here, we should be able to find the username named Lucas. Nope. We will see URL and webdev. So I'm mistaken here. This is not the correct file. Let's go back. And we're looking here for the CRM data that were exported. So basically, we're going to have to head back to D and maybe the files, since they are just documents, maybe we can find them in the users, Matthew, and then documents, CRM exports, users, export.csv, and we have customer export. So our guy here is, it's not clearly defined whether Lucas is a user, just like from the team of the hack corporation, or just a customer. You can assume it's a user. Can I copy this? Okay. Opening up this file using Notepad again. Okay, let's search for Lucas. And we have a match, Lucas Rivera. That's the username, and it looks like it is an employee at Deceptech. So basically, we're gonna copy this and wrap this up. So that was it.